I'd like to welcome everyone, including the Danbury Robotics Club, to John J. McCarthy Observatory. This is our second Saturday STARS event for September. My name is Parker Moreland. How many of you have ever been to one of our talks before? Quite a few. Tonight is not going to be like the usual JJMO second Saturday STARS talk. They are usually about astronomical discoveries, space exploration, tools and techniques of astronomy and what have you. Tonight, not that. Different. As you can probably tell by the title. Has anyone seen the title on our website by any chance? Oh, go to the McCarthyObservatory.org website. That's where you find out what we're going to do on Saturday night. I'll tell you about it in a minute. But first, we're going to talk about the cosmic perspective. Everybody knows what I'm talking about? Not yet. It's more philosophy, point of view, frame of reference type of thinking. People started, by the way, I need to tell you that my co-author is Elaine Green. She had the idea for this talk and has provided many of the resources that I'll be using tonight. Unfortunately, she can't be with us tonight, so I'll be giving the talk. About 400 years ago, when telescopes and microscopes were invented, scientists who used those tools started getting an inkling of a cosmic perspective because they could see very, very small things and things that were very, very far away, and it turns out they were very, very big as well. So that scale of the universe started percolating into their minds because they had the tools to see it with. That was about 400 years ago. Then about 100 years ago, tools had improved, and then Mr. Hubble taught us that, gee whiz, beyond those stars that we see, which we now understand are in our galaxy, the Milky Way, there are other galaxies out there, and they are very, very far away. Meanwhile, physicists 100 years ago were discovering that the atoms that the chemists had been playing around with for years really consisted of protons and neutrons and electrons in the atom. That was about 100 years ago. And of course, since then, we've made a lot of progress. But it was mainly restricted to scientists, astronomers, those kind of people who had access to these tools and had to think this way in their trade. And then 1968 dawned, and I know that one of my colleagues has already been giving away my talk. But in any event, does anyone remember what happened in the United States or what was happening in the United States in 1968? And it's okay if you got it from my colleague. Yeah.
Well, let's see. I know Martin Luther King.
What?
Martin Luther King.
He was assassinated in 1968.
And Kennedy killed.
Robert Kennedy was assassinated.
3 months apart.
That's right. And then that was a bad year for the United States in Vietnam. You may remember that. You may remember the riots in Chicago at the Democratic National Convention. But in late September of that year, NASA launched a Apollo 8 lunar module to the moon. It was not a landing, and I'm not going to answer questions, I'm just going to talk. It was not a landing on the moon. It orbited the moon 10 times and came back. But while they were there, this picture was taken. It has become famous. It was broadcast around the world in 1968. It has acquired the name Earthrise since then. And that's kind of a strange name in a way, because if you're on the moon, there is no Earthrise. You know, I hope you know, that the moon always faces up one side to us all the time, 24/7, right? So there's the other side of the moon we never see. If you're on the other side, that means you're never going to see the Earth. And if you're on this side, you're always going to see the Earth. So there's no rise, it's just there. But if you're in a spacecraft orbiting the moon, and you orbit from the dark side and you come around toward the near side of the moon, as you get there, you appear to see the Earth rising above the limb of the moon. True?
Yeah.
And of course, this is the moon down here, right? And that's the Earth. That was the first time that the world ever saw the Earth in this perspective. From 250,000 miles away, a blue marble in a dark void. So the cosmic perspective finally started leaving the domain of the scientist and coming into the ordinary people with this particular picture, because we have never seen the Earth from that perspective before. So that started things. That was 1968. In 1977, early in the space age, Voyager 1 spacecraft was launched to explore Jupiter and Saturn. Anybody remember the Voyager? There were two of them. We're going to talk about Voyager 1, the first one that was launched. And as it left the solar system in 1980, Carl Sagan suggested that an image of Earth be taken from that vantage point. Has anyone here ever heard of Carl Sagan?
Yes.
Okay, I hope so. He was the first recent proponent of this idea of a cosmic perspective. And he had it in his mind and he wanted to share it with people. So he suggested to NASA that when they're out there beyond Neptune, the edge of the solar system, they look back and take a picture of the Earth. Well, by the way, let me tell you a little bit about Carl Sagan. In 1980, he produced Cosmos, which played on PBS and has replayed over the years. And then it was recreated again a few years ago by the other proponent that I'm going to talk about tonight of cosmic perspective. Anybody know what his name is? Neil deGrasse Tyson. So we'll talk about him in just a few minutes. But first we're going to talk about Carl Sagan, who came earlier, because finally in 1990, NASA agreed and took the images of the solar system, including Earth. The part of the image that includes Earth, centered in an artifact band of reflected light, has become known as the pale blue dot. These really significant pictures get names, get their own names. I showed you Earthrise, correct? Here's the pale blue dot. Now these, as I said, these are artifacts. These colored bands are artifacts of light in the camera system. The only thing that's really there, inside the blue circle, you see Earth in the black void of space. And this was what they took in 1990 at Carl Sagan's long quest. 10 years earlier, he started requesting it 10 years earlier, and they finally did it. And of course, this is the same sort of thing as Earthrise, except more so because you're going out of the solar system at this point. You can barely see it. So that's the pale blue dot. Carl Sagan wrote a book by that name, by the way. So I found, after 1990, he was a professor of astronomy at Cornell University. As I say, he worked with NASA on the Voyager and Pioneer spacecraft. And he gave speeches about the pale blue dot and segued into this cosmic perspective idea for the next 6 years. He unfortunately died in 1996 at 62 years of age. Very unfortunate for the world of astronomy. Now I'm going to go over to Neil deGrasse Tyson. He's still alive. He is the director of the Hayden Planetarium in New York City. In the early 2000s, he wrote a monthly article on astronomy for Natural History magazine, which is the journal of the American Museum of Natural History in New York. And in the April 2007 edition, his topic was the cosmic perspective. And so I'm going to read for you, and you can read with me, the first part of this particular article. The correct topic right is what we're talking about. Let's see what Neil deGrasse Tyson has to say about it. He starts off with a quote from a James Ferguson written back in 1757. See, that's in that first 400 years I told you that some people are beginning to think about these sorts of things. Of all the sciences cultivated by mankind, astronomy is acknowledged to be, and undoubtedly is, the most sublime, the most interesting, and the most useful. For by knowledge derived from this science, not only the bulk of the earth is discovered, but our very faculties are enlarged with the grandeur of the ideas it conveys, our minds exalted above their low contracted prejudices. Now Tyson goes on to write, long before anyone knew that the universe had a beginning, before we knew that the nearest large galaxy lies 2.5 million light years from Earth, before we knew how stars work or whether atoms exist, James Ferguson's enthusiastic introduction to his favorite science rang true. Yet his words, apart from their 18th century flourish, could have been written yesterday. But who gets to think that way? Who gets to celebrate this cosmic view of life? Not the migrant farm worker, nor the sweatshop worker, certainly not the homeless person rummaging through the trash for food. You need the luxury of time not spent on mere survival. You need to live in a nation whose government values the search to understand humanity's place in the universe. You need a society in which intellectual pursuit can take you to the frontiers of discovery and in which news of your discoveries can be routinely disseminated. By those measures, most citizens of industrialized nations do quite well. Yet the cosmic view comes with a hidden cost. When I travel thousands of miles to spend a few moments in the fast-moving shadow of the moon during a total solar eclipse, sometimes I lose sight of Earth. When I pause and reflect on our expanding universe with its galaxies hurling away from one another, embedded within the ever-stretching four-dimensional fabric of space-time, sometimes I forget that uncounted people walk this earth without food or shelter, and that children are disproportionately represented among them. When I pore over the data that establish the mysterious presence of dark matter and dark energy throughout the universe, sometimes I forget that every day, every 24-hour rotation of the earth, people kill and get killed in the name of someone else's conception of God, and that some people who do not kill in the name of God kill in the name of their nation's needs or wants. When I track the orbits of asteroids, comets, and planets, each one a pirouetting dancer in a cosmic ballet choreographed by the forces of gravity, sometimes I forget that too many people act in wanton disregard for the delicate interplay of Earth's atmosphere, oceans, and land, with the consequences that our children and our children's children will witness and pay for with their health and well-being. And sometimes I forget that powerful people rarely do all they can to help those who cannot help themselves. I occasionally forget those things because however big the world is, in our hearts, our minds, and our outsized atlases, the universe is even bigger. A depressing thought to some, but a liberating thought to me. Consider an adult who tends to the trauma of a child, a broken toy, a scraped knee, a schoolyard bully. Adults know that kids have no clue what constitutes a genuine problem because inexperience greatly limits their childhood perspective. As grown-ups, dare we admit to ourselves that we, too, have a collective immaturity of view? Dare we admit that our thoughts and behaviors spring from a belief that the world revolves around us? Apparently not, and the evidence abounds. Part the curtains of society's racial, ethnic, religious, national, and cultural conflicts, and you find the human ego turning the knobs and pulling the levers. Now imagine a world in which everyone, but especially people with power and influence, holds an expanded view of our place in the cosmos. With that perspective, our problems would shrink or never arise at all, and we could celebrate our earthly differences while shunning the behavior of our predecessors who slaughtered each other because of them. So that is our first glimpse at Neil deGrasse Tyson. I'm going to come back to him a little bit later. As we've mentioned already, part of the cosmic perspective is understanding the scales of the universe, from the very, very small to the very, very large. Remember, that's where we started earlier, microscopes and telescopes. In the 70s, a husband and wife team of architects put together the movie I'm about to show you. So this is an old movie. It is not HD TV, sorry. But it's very well done, and it's been shown millions of times, especially in science classrooms. I used to show it to my classes. And it does a nice job of giving you this feel of the scale of the universe. It's called Powers of 10. You'll see. Does anyone know what Powers of 10 means? Yeah, 10 to the 0th is 1, 10 to the 1 is 10, and on up. 10 squared is 100. So you'll see that all throughout. That's what he uses as his reference point. The well-known physicist at the time, Philip Morrison, is the one who narrates this. Like I say, it's old, but good. Can you hear it? That's the husband and wife team.
The picnic near the lakeside in Chicago was the start of a lazy afternoon, early one October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Powerboats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters. The distance an orbiting satellite covers in 10 seconds. Long parades of clouds. The day's weather in the Middle West. 10 to the 6th. A 1 with 6 zeros. 1 million meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets. Venus, and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun. Followed by the massive outer planets, swinging wide at their big orbits. That odd orbit belongs to Pluto. A fringe of a myriad comets too faint to see completes the solar system. Ten to the 14th. As the solar system shrinks to one bright point in the distance, our sun is plainly now only one among the stars. Looking back from here, we note 4 southern constellations, still much as they appear from the far side of the Earth. This square is 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy, and as we pull away, we begin to see the great flat spiral facing us. The time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. The 2 little satellite galaxies of our own are the clouds of Magellan, 10 to the 22nd power, 1,000,000 light years. Groups of galaxies bring a new level of structure to the scene. Glowing points are no longer single stars, but whole galaxies of stars seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. As we approach the limit of our vision, we pause to start back home. This lonely scene, the galaxies like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception. The trip back to the picnic on the lakefront will be a sped-up version, reducing the distance to the Earth's surface by 1 power of 10 every 2 seconds. In each 2 seconds, we will appear to cover 90% of the remaining distance back to Earth. Notice the alternation between great activity and relative inactivity, a rhythm that will continue all the way into our next goal, a proton in the nucleus of a carbon atom beneath the skin on the hand of the sleeping man at the picnic. Ten to the 9th meters, 10 to the 8th, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point. We slow up at 1 meter, 10 to the 0 power. Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand. In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary containing red blood cells and a roughly lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus, so massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom. atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scheme, we reach the edge of present understanding. Are these some quarks in intense interaction? Our journey has taken us through 40 powers of 10. If now the field is 1 unit, then when we saw many clusters of galaxies together, it was 10 to the 40th, or 1 and 40 zeros.
Philip Morrison was the narrator down at the bottom. Well, that was done 40 years ago. Since then, we've discovered that the protons and neutrons are in fact made up of quarks, like he suggested. There's several kinds of quarks. And we found a whole zoo of other strange particles in high energy physics. And in the other direction, we've gone out beyond the galaxies that here he was. We have found groups of galaxies, and we found something called the Great Wall of Galaxies. There's structure among the galaxies when you go out far enough in space. So we have learned a lot in the last 40 years that he wasn't able to include in here. He would have if he had been living at this time. Now, I'm now going to show you a little app. It's on, you find it here somewhere. There it is. This is a little app that also tries to show you the scale of the universe. This was written by 2 Chinese high school students in California about 10 years ago. It's available for Windows computers and of course for Mac computers, and I've got it here on an iPad. And it is clever, and it's more up to date. They did it about, as I say, about 10 years ago. So if I pinch this, and come on in a little bit. Okay, you see what the size of 1 meter? The diameter of that gray circle is 1 meter. We've been using metric all the way through, right? You've been saying meters already. You use them in school too, right? So there's the human scale. See the human? And what they have done, we're just going to play with this for a minute. You can get it on your own computers or iPads or iPhones if you want to. Just look up Scale of the Universe 2, and I think it's free, but I'm not positively sure. But see what he does? I'm going bigger and bigger, am I not? And then if you tap on anything, like I'll tap on that, it tells you something about it, including how big it is. Okay? Does anyone know what Uluru is?
It's a giant mesa.
What's that?
It's a big mesa.
Where?
I'm not sure where it is.
I usually call it Ayers Rock, and it's in the middle of Australia.
Okay, yes.
But the native name is Uluru.
Okay.
Let's find out more about it. 3 kilometers. Wow. Oh, it says also known as Ayers Rock, 348 meters tall. And you know a meter is about a yard, so that gives you the scale.
39.
Okay. Oh, there's a neutron star. Does anyone know what Deimos and Phobos are? Those are the 2 moons of
Those are the 2 moons of Mars.
Mars. She's absolutely correct.
Oh, good job.
Yeah, and you notice they're not round. They're kind of funny. In fact, they're even rougher than the kids did this.
Just like
There's Rhode Island.
2 trains.
I think Desmonia is, I think that's one of the Kuiper Belt objects. Hydra and Nix are moons of Pluto. Grand Canyon, ooh, that doesn't look so big on here, does it? 1,000 kilometers, okay? That would be about 620 miles. California, Texas. Charon, the big moon of Pluto. There's Pluto and its big moon, Charon. And then these others are Kuiper Belt objects, Quaoar, Sedna, Eris. They're the moons of top row. Moons of what? And we're looking at Io, Europa, Ganymede, and Callisto. Those are moons of
Saturn.
what?
Saturn.
We got a conflict going on here. Jupiter wins the raffle.
Oh,
There's Earth.
I was close.
And, oh, what in the world is mine? Anyone know what Minecraft world is? Not me. There's Saturn, Uranus. 1,000,000 kilometers. Well, do you see how fun this thing is? Don't you want to go home and put this on your computer? Like I say, it's available for Microsoft or
Then,
Apple.
then there is time.
What are these? Are
The,
these
the
giant
Kuiper Belt,
stars
as you
that
know,
we're looking
is these objects that are out beyond Neptune.
at? Okay.
And our New Horizons spacecraft is out there in the Kuiper Belt, and it's supposed to be going past a Kuiper Belt object and taking pictures around the 1st of next year.
Okay.
Now we're getting into nebula, really big things out there. You see a light year, ring nebula. You can see that from here with our telescope, by the way. It's very good. There's a famous picture that NASA did, the Pillars of Creation. That's a very big object, big nebula. There's the Orion Nebula. It's a winter constellation, so you're not going to see that tonight, even if there were no clouds. Well, okay, I'm going to stop there. Is that all right if I stop there? You get the picture. You get the picture.
Yeah.
In fact, you get multiple pictures.
Groovy.
So let me go back to here. Now I'm going to play you a little bit of live Tyson, not much, on the, and this is a fairly recent video. Obviously the Sagan video was fairly old, but this one's fairly recent. In fact, you'll notice he's plugging the title of one of his latest books in here. This was on some TV show or other. But in any event, listen to the cosmic universe as explained by Neil deGrasse Tyson himself.
What I do care about as a scientist and as an educator, and in particular as an astrophysicist, is that everybody has some sense of a cosmic perspective. That's a point of view that resets how important you think you are, relative to yourself, relative to others, relative to nature, relative to the universe itself. Studying the universe realigns that compass. Apollo 8, 1968, was the first time we ever left Earth for another destination. They went to the moon. No, they didn't walk, but they went orbited 10, 15 times. In so doing, on one of those orbits, they lifted the Hasselblad camera, and there was Earth rising above the lunar landscape. Seen not as we had all been trained, with color-coded countries, no. They saw it as nature intended, with ocean, land, clouds. That view makes you care about Earth just a little more. Care about fellow humans on Earth just a little more. Maybe a lot more. To learn that your atoms are forged in the centers of stars that gave their lives billions of years ago, enriching gas clouds that would later form our star system, the sun, and surrounding planets. And on at least one of those planets, life, and a branch of that life called humans. We're not separate and distinct from the universe. We're not just alive in the universe is alive in us. That's a cosmic perspective. I think we are special because we are the same, not because we're different.
Well, all right, at this point, do you feel you have a little bit of a feel for what we're talking about when we use the term cosmic perspective?
Yes.
Do you wish that more people had the cosmic perspective?
Yes.
do you feel that it would be especially good if our leaders had the cosmic perspective?
Yes.
Well, now I'm going to interject my own thoughts in this and maybe raise some questions with you. 1800, in 1800, right around then, a British cleric by the name of Malthus had an interesting idea. Oh, wrong. He knew that organisms grow in an exponential way, exponentially. And that was of a concern to him. Of course, this is the Earthrise picture I'm showing again, right? And there's a reason for that. But first, let me explain the rest of the slide. Well, it doesn't seem to work on my iPad. This is a plot vertically of the population of the United States. And this is time along here. And being egotistical, like Tyson knew we were, I started with 0 in 1931 when I was born. And in 1931 when I was born, the population of the Earth was 125 million. And then if we look over here, I'm going to be 87 in a few weeks. If we look over here at 87, the population today of the United States is 325 million. And I have fit an exponential curve to that. And this is what worried Malthus. This exponential curve. By the way, this shows that we had about 40 million 100 years before I was born. It was really more like 25. But you'll remember back then, 100 years ago and up to the 1900s, we had larger families typically. Today, the average woman has little under 2 children. Back then, not so much, more. Okay, so the growth rate was actually larger then than it is now, but I fit an exponential to it because that's what bothered Malthus. He was worried that we were heading toward a human catastrophe. He thought we were going to run out of food. He didn't think we could find enough farmland and grow enough food to keep up with the burgeoning amount of people. Well, that was 200 years ago. We've done pretty good with pesticides and fertilizers and new ways of farming and bulldozers to clear new farmland and what have you, things like that that he couldn't dream of. And so, by and large, food's still not a problem, is it? Can't you go to Stop and Shop and get food? But you also know that there are large parts of Africa, Indonesia, China, where people are starving today. Very much about this. North Africa is losing farmland to desert. True? So in a way, he was right. But it's worse than Malthus thought. We also are going to be having an energy shortage. We're running out of fossil fuels. And we're not putting in sustainable fuels fast enough, are we? And then what's the other thing that he didn't think about back then that could come up and bite us? Anybody ever hear of climate change?
Yep.
Have you noticed that hurricanes are more frequent and stronger than they were? Same for tornadoes, droughts, fires in California and the far west. All of those things are brought about by climate change. And have you noticed what's going on in Florida? The freshwater aquifers are becoming saltwater as the oceans rise. Of course, currently, you know, there's a lot of red and green algae down there, but that's a little different problem. We better get some leaders who think with the cosmic perspective one of these days, because Malthus worry is going to be all of our worries one of these days. Okay, that's the end of my talk. I see people looking through the window. When is he going to get through in there? Normally we would open it up. We can have the lights. Well, normally we would open it up for questions. Now, I really can't think of any answers to give you about the cosmic perspective. Either you sense it and feel it, or you don't. Am I right? Yeah. Okay, could we have the lights? It's right by your, the switch is right by the door. White lights. The one closest to the door. The other door. Okay, you found it. Any comments from anybody? Was it halfway understandable?
Oh yeah. Thank you.
Okay. By the way, I've got another one here. Can you see that one? Can you read it?
Next month.
And then there's
Oh, really?
there's the last slide.